So here's what's going to happen with the rest of 12.1. Today, we're going to look at how to find a missing angle from a triangle, a right triangle. Yesterday we just worked with the ratios and got used to opposites, adjacent, hypotenuse, and where they all go. Now we're going to use that information to help us actually solve a triangle. So today we're going to find missing angles. Monday we're going to find missing sides of a right triangle. And that's the first sort of half of this chapter 12.1. Okay. So we've used sides of a triangle to write ratios like this. So go ahead and take a picture of that and then solve those three trig functions. Just those three. I don't need the other three today. In this case, we are looking in terms of respect to angle A in all of these, okay? Which forces well, first of all, the hypotenuse is 29. That doesn't change. Okay? It's opposite the right angle. Since we are at angle A, 20 has to be the opposite side. And that makes 21 the adjacent side because it is also next to angle A. Okay, so that's where I would start in terms of identifying all those sides. Then you should have had sine of A equals 20 over 29. Cosine of A is 21 over 29. And tangent of A equals 20 over 21. How many of you had those? Okay. So that's what we spent time doing yesterday. Today we're going to actually use that to figure out what angle A is. All right. One of the things I want you to notice about right triangles is, do you know how many degrees in total a triangle is? 180. 180, okay? So all the angles of a triangle always add up to 180. And in a right triangle, one of them is already 90, which means the other two have to add up to how much? 90. So A and C in this picture, in this diagram, A and C have to equal 90 in total. And that will always happen in a right triangle. That's something I want you to keep in mind. Okay? So let's talk about how to actually use this information to find angle A. All right? And so we can use those trig ratios to find the missing angles. And I'm going to show you how to do that on your calculator. That's just why you have it out. Now, I'm going to choose sine. Okay? Since we know that sine of A equals 20 over 29, we can use the inverse of sine, or also known as the arc sine, to solve for the angle. And on your calculator, above the sine button, you see a sine to the -1. That means inverse or arc sine. Okay, I want you to know both terms. The inverse of sine or the arc sine. For that matter, the inverse of cosine or the arc cosine. The inverse of tangent or the arc tangent. All of those are used when you're looking for an angle. So all of these inverse functions, these arc functions, get used when you're looking for an angle. Okay, so we're going to do that here. Before you actually do that, you have to check your calculator, because your calculator does not fault to degree mode. And I put the DEG in capitals because that's usually what shows up on your calculator. If you are not sure what mode you're in, hit the mode button. Okay? And this is something you're going to need to check, because I know that sometimes when your calculator's reset, it will default back to a different mode. And that different mode is something we will learn later. The fourth one down says radian or degrees. Okay, radian is something we're going to learn later. Make sure you're in degree mode. Okay, and on any of your calculators, whether it's one of the baby calculators or your graphing calculator, you have to ensure that you do this, because if you don't, your answers are going to come out wrong. Right?
Should degree be highlighted?
Yes. Okay. Anybody having an issue getting there or getting that done? So here's what you're going to do. In this case, on your calculator, you're going to enter sine, the inverse sine or arc sine of 20 over 29. Now, you are probably going to want to make sure all of that is in its own set of parentheses. Okay, I believe when you do the inverse sign, it'll give you a left parenthesis already. Just make sure you close it. And whether you insert it as a fraction or you insert it as 20 divided by 29, it'll give you the same answer. Okay? I want you to round your answer to the nearest tenth. And that will tell you the degree measure for angle A. Raise your hand if you're having an issue figuring it out. Raise your hand if you have an answer. Okay.
Wait, what do you mean it's a degree?
All right. Audrey, what'd you get?
No, I didn't.
Yep.
It's like,
Robert, what'd you get?
how do I know 43.6?
43 points. That is correct. Make sure when you tell me an angle measure that you label it with degrees when we're in degree mode and talking about degrees. How many had that?
How did you do that?
So, here's the thing on this problem though. Okay, I chose the arc sign just because. Right? We also knew the value for cosine and we knew the value for tangent. So, here's what I'm going to have you do. Alright, half of the room. So, right here, from Blake and John over, you guys are going to figure it out using the arc cosine. You guys are going to figure it out using the arc tangent. I just want to prove to all of you that it doesn't matter which one we use, that we still get 43.6. So again, you guys, John and Blake to the right of me, you're going to use the cosine now. And that means you're going to use the cosine ratio. Robert, Aiden, and Cece over, you guys are going to do the arc tangent. So same thing that we just did, but instead of using the value that goes with sine, you're going to use the value that either goes with cosine or tangent. So go ahead and do that now. So here's, okay, in these two cases, okay, go sit down. In these two cases, so if you're finding the arc cosine now, if you would have chosen that, you'd have to use 21 over 29 because that's what the cosine was. If you're doing arc tangent or inverse tangent, you use 20 over 21. So it would look a little bit differently than what we did for the inverse sign, but my point is that it's still angle A. The measure of angle A has not changed, which means all of this should still equal 43.6, which it does. Okay, how many of you had that? Still got 43.6. So here's the trick. Depending on which function you use, you will have to choose a different inverse function. Okay? Now, sometimes when you have all three sides, you can pick which one you want to use, and it doesn't matter. Most of the time, they're not going to give you all three sides still. And we'll get to a problem like that in a second. So let's start with this one. Okay? So here's another one. Okay, if you want to take a picture of that, you can. I'm not telling you what function you need to use. We have all three sides, but the key thing here is we are finding angle x. Find angle x. So in this case, you don't even have to use all the functions if you don't want to. You can pick the one you want to use and just use it. So you decide which one you want to do, and we'll go from there. So here's what we're going to do. U6 right here. You guys are going to use the sine.
Okay.
Okay? U5 right here, you're going to use the cosine. And you guys are going to use the tangent. Okay?
Wait, from which letter?
We're finding angle x. Okay? Sine, you guys are cosine, you guys are tangent. We should all get the same answer.
So wait, I have a question.
So, the thing is, you could find all three. You don't have to. So for you guys over here, on this side of the room, you should have just written down what's on top. You guys in the middle should have written down what's in the middle, and you guys on the right should have written on the bottom. All three of these will give me the same answer. They should anyway. Okay, and my point is, when you get to a problem like this, you have the choice. You don't have to do all three. If you want to do it a second time just to verify that you did it right, that's fine. But there's no reason to do that. Okay? And my point is you have some choice involved here in this particular kind of problem. All right? How many had these set up correctly? whichever one you were assigned. Okay, so what's the angle measure? 53.1 degrees. Okay. Okay.
I did that and I did not get that answer. I put it.
Okay. Next, so most of the time you're only going to have two sides. So when you have those two sides, it's going to tell you which function you're going to use. Okay, because there's no reason to find the missing third side. Let's just use the two sides to find the angle. So I've got two problems for you. Okay, and this is on page 1779 in your book if you want to use it there. But because of the fact that in each of these two problems only two sides are given, you should use the function that is associated with those two sides. Okay, so let's go through A real quick and you'll get a sense of what I mean. Okay, I'm looking for angle N, so I'm over here. Which sides am I given in relationship to N? Opposite and hypotenuse. Which function should I use here? Sine. So I should use the inverse sine to find angle N. Then you would go through that same process over here for this triangle. So go ahead and do those two problems. We're finding the angle round to the nearest tenth. So on this first one, here's what you should do. Okay, and somebody asked the question, should I reduce 6/10? You can, but you don't have to. We're not focused on that ratio itself. We're focused on using that ratio. So when you enter this in your calculator, you've gotten 36.9 degrees. How many had that? Okay, good. So for the second one, right, we're focused on angle B, which means which sides do I have in relationship to angle B? Adjacent, and hypotenuse. So which function am I using? Cosine. So inverse cosine 8/16 should give you 60 degrees. How many have that? Okay, a couple things to keep in mind, and I'm going to say this over the next few days a lot. If you're looking for an angle, you're going to be using the inverse or the arc function. On Monday, when we start looking for sides, you're not going to use inverses. You're going to use just the regular sine or cosine, okay, or tangent. We won't use the other three functions to find angles or to find sides. All right, that was really more of an introduction so that you've seen it before, but we're not really going to use it that much, okay? Any questions about any of this?